Okay, then question 12. Here are the ages in years of 15 people. Show this information in a stem and leaf diagram. And this is set out nicely. Apologies. So the way that this is set out for you is to do an unordered one first, followed by an ordered one, or to order the numbers first and then do an ordered stem and leaf diagram. All right. So I'm going to do that. So I'm going to do am I going to do an unordered one first? Yeah, we'll do an unordered one first. So stem and leaf diagram splits a number into it. A stem, which in this case is going to be tens, and a leaf, in this case, that's going to be units. So I'm going to go 1, which is my largest, 2, 3, 4. I can't see anyone less than 1 or greater than 4. Going to go 19, cross it out, 28, cross it out, 29, cross it out, 33, cross it out, 27, cross it out, 27 again, cross it out, 37, 25, 27, 37. Oh, I believe I put that 27 in the wrong place. And I've lost my count. So let me just double check that. So 19, yep, 28, yep, 29, yep, 33, yep, 27, yep, 27, yep, 37, yep, 25, yep, 27. I put in the wrong one. 37, 17, 45, 47, 25, and 26. So double check that I've got 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's my unordered. Now I need to order them. So I'm going to do the same principle. So my stems are going to be 1, 2, 3, and 4. And now I need to put them in size order. So instead of writing 9 and 7, I would write 7 and 9. And then I do my twos. So in my twos column, I've got 2 5s. Then I've got 1 6. Just checking 2 5s, 1 6, 3 7s, and an 8, and then a 9. And then for my threes, I've got 3, 7, 7. And then for my fours, I've got 5 and then 7. And I'm just going to check because I was worried that I'd done my twos column wrong. So I should have 1, 2, 3, 4, 5, 6, 7, 8 values in the 20s. So let's just double check. 1, 2, 3, 4, 5, 6, 7, 8. Is that right? Is that what I said? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So I'm fairly confident with that. I can double check that at the end of the paper if I have time. For my key, I used to try and make this as complicated as I can, but the trick is, well, not the trick. I now make it as simple as I can for my marker. 1/7 equals 17. And that's it for that question. And then finally, simplify E plus E plus E plus E. Well, we've got 4 lots of E, so 4E. Right, and the marks for this tend to be fairly straightforward. It is 1 for unordered or 1 for a complete stem and leaf diagram. What does it say? B2, these marks are given for fully correct ordered diagram. B1 for unordered. So arguably, I'd get 2 marks there. But if I hadn't got those 2, I could pick up 1 for an unordered and then 1 for the key. Right, and 1 mark for 4E. Okay, question 23, solve. So another solve. So this time to get rid of a -3, we would add 3 on both sides. So m would be equal to 7. And then solve, this time we need to simplify. So 3n plus n would be 4n is equal to 24. Divide both sides by 4. N would be equal to 6. Right, question 24 then. We've got an adding of fractions. We can only add fractions when we have them over the same denominator to the same bottom number. So currently, the lowest common multiple of 12 and 6 would be 12. So I'm going to keep the first fraction the same, but I'm going to double the numerator and the denominator of the second fraction. So that would be 2 over 12. And then when I add those, now I've got them as the same denominator, I add the numerators. So that would be 7 over 12. And for question 25, a multiply, giving your answer in its simplest form. So I'm going to show two methods for this one. So I'll call this M1 and I'll call it M2. I'll show my preferred method first. So I'm going to multiply the fractions. Before I multiply them though, I'm going to simplify. So I can simplify diagonally. So 5 goes into both those numbers. And that's the simplification I can do. So then 3 times by 1 is 3, 2 times by 8 is 16. Alternatively, if I hadn't spotted or didn't feel comfortable cancelling diagonally, I could have done the multiplication, slightly harder multiplication, but no real drama. 3 times by 5 would give us 15, 10 times by 8 would give us 80, and then we need to cancel down by 5. So 5 goes into 15 3 times, and it goes into 8 16 times. So get to the same point, just I prefer cancelling before I multiply. Either way, 3 out of 16. Right. Question 25. Eleanor spends 120 minutes at a sports centre. She plays badminton for 50 minutes. She used the swimming pool for 1/6 of the 120 minutes. She uses the gym for 20% of the 120 minutes. She then spent the rest of the 120 minutes in the cafe. Work out the total time she spent in the cafe. Okay, so the activities that she's got then. So I'm going to try and extract this information. She played badminton. She went swimming. She went to the gym. And she went to the cafe. And she had a total. So I'm going to just start by putting the information from the question. They're not going to be in a similar format yet. So just from the question, not the actual time. So we know that there's a total of 120 minutes. We know that she spent 50 minutes playing badminton. She spent 1/6 of the time swimming. And she used 20% of the time in the gym. And the rest of the time she spent in the cafe. Right, so the actual times then. So 50 minutes, 1/6 of 120 is the same as 120 divided by 6. So she spent 20. She spent 20 minutes swimming. 20%, well, 10% would be 12, so 20% would be 24. So we've so far spent 50, 60, 70, 80, 94 minutes. 94 minutes. So she's got 24 minutes left to spend in the cafe. No, I've done that slightly wrong. So let's do that again. 50, 60, 70, 80, 94 minutes. 94 minutes would be 26 minutes left over. Eleanor got to the sports centre at 1:30. She asked her friend to meet her in the cafe at 3 p.m. Did Ellen get to the cafe by 3 p.m.? Give a reason for your answer. So she's spent 94 minutes so far, which is 1 hour and 34 minutes in the gym. So if I add an hour and 30 minutes to, 1:30 plus an hour and 30 minutes, 34 minutes, sorry, that would actually take me to 30 plus 34 is an hour and 4 minutes. So she would actually get to the cafe at 3:04. So no, she would get there at 3:04 p.m. Okay, and if we 26 change 40 centimeters into millimeters, well, 1 centimeter is equal to 10 millimeters. So 40 centimeters would be equal to 400 millimeters. Right, and marks for that then. So for question 25, what have we got? A P1 for showing 20 minutes, so a mark for that. A mark for 24 minutes. A mark for the method to find 26, and then a mark for 26. And then for the second one, we've got no. What does it say? No, she would be late, for example. She arrives at 3:04. So there we go. Right. Question and marks for 26. Then it's just a B1 mark for 400. I haven't made that 0 very clear, but it's shown quite clearly there as well. Right. Question 27. We've got a composite bar chart, shows information about the number of people living in a village. So we've got the village, we've got children, women, and men. Write down the number of men living in the village in 2000. So 2000, we find that men is the grey box. So this is our value. Reading this off, we've got 10 squares. So each square is representing 10 people because we've got 100 shown here. So we're looking at 6 squares would represent 60 people. Find the number of children living in the village in 2010. So children is the light shaded box. So that's where it starts and that's where it ends. So again, we've got 1, 2, 3, 4 spaces. And I'm looking at the wrong year, aren't I? So should have been 2010 and I was looking at 2000. So we're looking at between that value and that value. So we've got 1, 2, 3, 4, 5 squares. So that would be 50 children. And part C, for the people living in the village in 2020, find the ratio of the number of children to the total number of men and women. So we're only looking at this year. So the number of children, so children to the total number of men and women. So men plus women. So for 2020, the number of children, we are looking at what looks like 80. And then the total number of men and women is 200. Does it say in the simplest form, find the ratio of the number of children, men and women? So I think I would get away with that. But if I simplified that fraction down, I would be going for 40 goes into them both. It goes twice. And then 40 goes into that one 16 times. Let me simplify it down a little bit better. 8 to 20, which is going to be 4's going to the both of those numbers, 2 to 5. Yeah, so 2 to 5 would be my simplified ratio, but it doesn't really ask for it. Right. Marks for that then. So my first mark, 60 is correct. My next one is 50. I've then got for this one, P1 for either showing that value or that value, and then 1 mark for the ratio. Didn't need to simplify it. Would still get the mark for simplifying it, provided I'd simplified correctly. Right, question 28. There are only blue counters, green counters, red counters, and yellow counters in a bag. The table shows the number of blue counters in the bag. There are a total of 100 counters in the bag. Asheen takes at random a counter from the bag. Find the probability that the counter is not blue. Well, if we've got 30 blue, if we've got 30 blue, then that means that there are 70 other counters. So it would be 70 out of 100, which I would go 7 out of 10. Part B, the ratio of the number of blue counters to the number of green counters is 2 to 3. Work out the number of green counters in the bag. So we've got blue counters to green counters. Let me just look at the table again for a second. Right, slightly struggling. The ratio of the number of blue counters to the number of green counters is 2 to 3. Work out the number of green counters in the bag. I don't think we've been given enough information because we don't know how many yellow counters there are in the bag. Let me just reread the question. There are only blue, green, red, yellow counters in the bag. The table shows the number of blue counters in the bag. There is a total of 100 counters in the bag. Find the probability that it is not blue. Okay, I'm fine with that so far. The ratio of the number of blue counters to the number of green counters is 2 to 3. Work out the number of green counters in the bag. I don't think we've got enough information to do this. Let's just have a quick look at the mark scheme. All right, what does the mark scheme say? I'm being very, very dense here. So we know that. So I was misreading the question. So we're not dealing with green and red. We're dealing with blue and green. Okay, so that makes it much more sense. So if we've got 2 to 3, and we've got 20 blue counters, then we must have 30 green counters. And I've done that wrong. Great. So I've misread again. We've got 30 here. So we times by 15. So if we times by 15 here, we would have 45. There we go. Right. Bradley says the number of red counters in the bag is the same as the number of yellow counters in the bag. Can Bradley be correct? So let's think about how many counters we've got used so far. So we've got 45. So currently we've got a total of 75 counters. So 25 of the counters must be red or yellow, and we can't have the same number. So there are 25 counters left. 25 counters left. Left, which can't be split evenly. Right, marks for that page. We have got 70 out of 100. So one for the method, one for the answer, although 70 out of 100 would be fine. For the second part, we've got P1 for showing 15, and then an answer mark. So mark there and mark there. And then for part C, Bradley is not correct. For example, the total number of red and yellow counters is 25, which cannot be divided into 2 equal whole numbers. So there we go. That's fine. Right, question 9. Work out an estimate for 92 times by 1.63. 2 marks, so real quick question. So we're going to estimate those values. So 92 is roughly 90 to one decimal significant figure. 1.63 is roughly 2. So 90 times by 2 is 180. Right. Given that 2.96 times by 3.2 is 9.473, work out the value of this. So this number is 10 times bigger. This number is 10 times bigger. So we should have a number that is 100 times bigger. So 947.2 is how I would do that question. Right, simplify. So collect like terms. So, well, no. We can simplify our 3 times by 5 would give us 15. And then W times by T, we're going to say is WT. Right, marking for that page, then we have for the first part, what does the mark scheme say? M1 for rounding to appropriate, for example. So 1 mark for that, or for, let's go for the first one. 1 mark. Does it say and? It says or, 92 or 90 or 100 or rounding. Right, so there we go. For the second part, we have got just 1 mark for the answer. And for the third part, sorry, for question 30, again, 1 mark. And we could have had it as 15 TW. That would probably be a slightly more mathematical, letters in alphabetical order, but still fully correct. Question 31, a delivery company has a total of 160 cars and vans. The number of cars to the number of vans is 3 to 7. Each car and each van uses electricity or diesel or petrol. 1/8 of the cars use diesel. 25% of the cars use diesel. The rest of the cars use petrol. Okay, so we're really just looking at cars. So what I'm going to do is I'm going to work out the number of cars first of all. So the number of cars is going to be 3/10 because we've got 3 out of 10 parts times by 160. I'm going to treat that 16 times by 10. No, I'm not. I'm going to treat it as 3 times by 16, which would give us 24, which would give us 54 cars. So if we've got 54 cars, double checking my working here. 1/8 of the cars use electricity. So 1/8 times by 54 is going to be equal to, well, 54 divided by 8 is going to give us 36. I've made a mistake. Right, let's just clear this up before we go any further. So I'm going to change that to being 3 times by 16. And then 3 times by 16 would give me okay, I was doing times by 18 for some reason. So 3 times by 16, 6, 12, 24, 54. Oh, struggling today. 3 times by 6 is 12, 18, 48. That's better. And then 48, 1/8 of 48 would be 6. So we've got 6 cars use electricity. 25% of the cars are diesel. So 25% of 48 would be equal to halve it and halve it again. So that would be equal to 12. The rest of the cars use petrol. So if we've accounted for, so we need to do 48 minus the cars that we've accounted for, which was 18, which would give us 30. So how many cars use petrol? We're looking at 30. And that's it for that page. Right. So we've got 1 mark for 16, 1 mark for 48, 1 mark for 6, 1 mark for 12, and then 1 mark for 30. There we go. That's the 5 marks. Right. 32. Final question. Right. 500 as the product of its prime factors. So I'm going to break this down. Normal way for me, 2 and 250, which would be 2 and 125, which would be 3 and 45. No, it wouldn't. 40. 3 doesn't go into that, being a bit dense there. 5 and 25, which is 5 and 5. So as a product of its primes, we've got 2 squared times by 5 cubed. Right, and then marks for that we have 1 mark for finding a factor. So we could go there. 1 mark for finding the full factor tree, 1 mark for the answer. There we go. Okay, so that is all 32 questions. That brings us to the end of the paper. Quite a nice paper. I'll show you the back of the mark scheme now, just nice and quick because it's quite useful. So if you go back and look through any questions that you particularly struggled with, this will give you a topic list. Right. There we go then. So each of the questions is linked to a skill. If you struggled on a particular question, that gives you the skill that it related to for any additional revision that you feel you may need. Suggested grade boundaries for that paper then is if you're getting 70 or above, you're looking at really sort of a grade 5, or 60. 2 is a grade 4. They're recommending 52 for a 3, 40 for a 2, and 30 for a 1. Thank you very much for your time in listening to the video. Feel free to add any comments to whatever format it appears, either in Teams or on my YouTube channel. Thank you for your time, and I will see you soon.